So, welcome back, students, to the course of CAPOL 208 Computer Graphics and Multimedia. So, this is SENTHIL SELVAN. So, I'm taking unit number 5. So, the today's topic is video compression techniques. So, last session we saw about image formats, bitmap image format, different image file formats we saw. So, this session we are going to see about the video compression techniques. So before going to this, compression, why we are going for compressions? So because to save the memory spaces. So for that purpose only mainly we are going for compressions, and at the same time while transforming the informations, the video, so it's huge in size. So if we compress it, we'll send it. So the bandwidth we can use it efficiently. We can utilize it. So that's why we are going for video compression, because videos occupies more memory space. So compression, so different types of categories there. So one is lossless, lossy compression techniques. So lossless compression technique implies the original data is not changed permanently. So during the compression, so after the decompression, the original data can be retrieved back exactly. So coder we will use that, so it will do all this task. So lossless in the sense informations we won't lose it, but lossy compression, so we'll reduce the memory size, but actually we'll lose certain data. So prominent features, so the prominent frames, it will hold it. So with the help of that, so it will regenerate the original image, but some drawback was there. So after applying encoder decoder, after decoding we'll get the original image, but with some missing informations in the video. So that is lossy compressions. And intra-frame, inter-frame compression technique also there. So intra-frame, so compression, as the name implies, it's applicable within a single image, video frame. So but the inter-frame image means so across image frames we'll check. So same during in animation, so same kind of objects appear there. So without any movement means simply easily we compress it. So for that purpose we are using that. So inter-frame, intra-frame. And now we'll move to the actual video compression format, that is MPEG 1, 2, and 4. Before that, so what is MPEG? I'll tell you. So it's a moving picture experts groups. It's developed in 1960s, 50s, 70s, and these groups developed these algorithms, MPEG 1, 2, 3 compression algorithms. So the categories 1, 2, 4 is there. Still a lot of compression techniques are available, but as per your syllabus, so 1, 2, 4 only it's included here. So we'll see one by one. So MPEG 1, 2, and 4. So MPEG stands for Moving Picture Expert Group. So it's an ISO committee. So who actually frame this. So the main goal of this, so MPEG 1 compression technique, it compresses a video signal, so it contains audio also, to a data stream of 1.5 megabits per second. The data rate of a T1 link in states, and the rate that can be streamed from a CD-ROM. So in that speed, so it will transfer the informations. The goal of this MPEG 1 compression algorithm is, I'll take a pointer. So random access within 0.5 second while maintaining a good image quality, so for the video. So it's so fast forward remains, so easily we can do it here, and possibility to play the video so backwards, allow easy and precise editing. So these are some goals of this, and mainly the MPEG 1 video standards. It's completed in 91 with the development of ISO IEC specification 11172 with the standard for coding of the moving pictures and associated audio for digital storage at about 1.5 megabits per second. This provides for the VHS very high resolution, so quality video and audio. It was developed for CD-ROM applications to suit a range of applications. The users can specify a set of input parameters, including the frame size, actually the horizontal vertical frame size, the frame rates. So nowadays we are having laptops, high-fi laptops, gaming laptops with 144 hertz, so frame rate per second, so like that. But frame rate, so we have to choose. So the important features provided by MPEG 1 includes the frame-based random access of video, and I told it in the previous slide, the fast forward, fast reverse searches, so reverse playback of video, and editability of the compressed bit stream to achieve a high compression ratio. So in this MPEG 1, so both the intra-frame and the inter-frame redundancy are exploited here in the MPEG 1 so category. So the DCT, discrete cosine transform, so coding is used to remove the intra-frame redundancy, and the motion compensation is used to remove the interframe so redundancy. So though it offers a large variety of sizes, different sizes, we can fix the frames. The coder is optimized to SIF formats, which resolutions of up to 352 by 288 pixels. Although this format, SIF, so calls for a horizontal resolution of 360 pixels. So since each frame is divided into macro blocks of 16 by 16 pixels, so the horizontal resolution is reduced from 360 to 352 pixels to produce an integral number of 222 macro blocks. This is the specifications. And the MX1 video uses three different types of frames, which is represented in this slide. So I frame, P frame, and B frame. So this I frame is intra frame. So intra-coded full image, very similar to JPEG. So image encoded with discrete cosine transform. So quantizations. So run length encoding, upper encoding algorithm and all they used here for the compression techniques to reduce the memory sizes. And what about the P frame here? So P frames. So uses delta encoding. These require information from the previous I frame for encoding and decoding by exploiting the temporal redundancies. The achievable compression ratio is higher than that of the iframes here. Vframes can be accessed only after the referenced I or P frame has been decoded. Encoding of the P frames is done using the combination of frame replenishment and motion compensations. So the number of P frames, so in a group of picture, they call it as GOP, is however limited. So since any error present in a P frame will be propagated to the next level. So the number of frames between the P frames and the preceding I or P frame is called the prediction span, and typical range of value is from 1 to 3. And what about the B frames? So bidirectional predictive frames. This bidirectional predictive coded pictures, the B frame refers to the preceding and succeeding frames, interpolated the data and encodes the differences. So what about the D frame? So the D frame, so DC coded pictures. Only the DC coefficient of each block is coded on upper left corner of the matrix. So that is what D frame will do. So group of picture GOP impact. The sequences of I, P, and B frame is not standardized but can be chosen according to the requirement of the applications. So based on it, so they will choose the order of I, P, and B frames. This allows the user to choose his or her own compromise between the video quality, compression rate, and is easy to editing. So this is the sample is given here. So based on the application, the quality requirement, so you choose the IPB frames in any order. So this is the MPEG encoder actually. So frame memory is there. So the input is applied to the discrete cosine transform. So after that, we are giving it to the quantizer. So quantizer, it will split out images and it will identify the entropy level. Then inverse quantizer was applied in this reverse order. So inverse IDCT was applied here, so which is given to frame memory. So once again, the reverse the feedback is given into the from the motion compensation to DCT. And finally, encoder, it will provide the information, and that image, the data was stored in the memory space. So this is the working of the encoder, and the decoder, the reverse order. So it will do this process, that is inverse quantization. So inverse DCT, discrete Gaussian transforms. Then the data was fed to the previous picture store, future picture store for the multiplexer, and once again that feedback was given to the XOR gate. So finally it will produce the final video. So in the decoder, the receiver side. So temporal redundancy and motion vectors. So motion compensated, so interpolation, so how it's happening between the current frame, previous frame, and the next frame. So what is the difference? So they will check it out. So block matching, so technique they used it. So they're calculating on the encoder side the search range. So can be chosen as a parameter. The larger the search range, the higher the potential for compression. So it might happen, but the longer the runtime of the algorithm. Yes. So ultimately we can achieve either good compression, but it will take longer time, or compression will be very minimal. So but algorithm will complete at the earliest. So now students, we can move to the next video compression technique, which is MPEG-2. So next version of moving picture expert groups, they introduced this particular standard in 1994. Specifically, so the MPEG-2 was developed to provide the video qualities, so not lower than and up to the HDTV quality. Some specification is there, so below that, so they don't want to reduce the quality of the videos. Its largest bit rates are 2 to 15 Mbps. So in MPEG, so one it was very less, but here so they are going 2 to 15 megabits per second, and it is optimized at 4 megabits per second. The basic coding structure of this MPEG-4, so it was developed jointly by ISO and IT2, and its scalable data streams which allow the receivers with different bandwidth and processing power to receive and decode only the part of the data stream. And the scalability in MPEG-2 is SNR scalability and spatial scalability. So each frame is encoded in several layers. So a receiver who only decodes the base layer will get a low image quality. A receiver decoding additionally higher layers gets a better image quality. So this option is available here. An example is the color subsampling. The base layer contains only 1/4 of the value for UV component, UV rays, compared to the Y component. The enhanced layer contains UV component in full resolution for better color quality. And about the spatial scalability, the frames are encoded with different pixel resolutions. For a standard TV to high definition TVs, that is 800 cross 600 to 4000 cross 4000 something 562. So both the encodings are transmitted in the same data stream, same rate. And the scalability, temporal scalability, and the data partitioning. Temporal scalability, the base layer contains only very few frames per second. So the enhancement layers, additional frames per second will be included. The receivers decoding the higher layers will thus get a higher frame rates. Then data partitioning. So coming to data partitioning, the data stream is decomposed into several streams with a different amount of redundancies for error corrections. The important part of these streams are the encoded in the base layer, which is the low frequency coefficients of discrete Gaussian transform and the motion vectors. This layer can then be enriched with error correcting code for better error realizing than the enhanced layers where errors are not as harmful. So this is the video profiles. So for each of the above 4 levels, so different resolution is there. MFO2 provides for 5 profiles: simple, main, spatial resolution, so quantization accuracy and high. At a given level, the decoders for the given profile would be able to decode all the lower profiles that have been defined for that level. So this provides for scalability. So in the standard So since the low level is compatible with MPEG 1, so we just discussed here about the higher profiles. So simple profile, no B frames, so it's not scalable. So main profile B frame is there, but still it's not scalable. But the rate, data stream rate is 60, 80 megabits per second. SNR scalable, so profile B frames and scaling was possible here at the main level and low level. Spatial scalable profile B frame, spatial scalable. So it is working in the high level at 1040, and the frame rate is 60. So high profile range to B frame spatial or SNR scaling. So it's 100 Mbps. It's working for high level, so high main level also. So coming to MPEG 4. So MPEG 4 is still so advanced than the MPEG 1 and MPEG 2. So MPEG 4, so originally ISO and IT2 organization had planned a standard of MPEG 3 for HDTV. So at very high bit rates, this work was later integrated with the MPEG 2. This explains why there is no MPEG 3 standard. So that's why they integrated the 2 itself. So that's why 4 standard came. MPEG 4 is also known as MPEG 4 Part 2 or MPEG 4 ASP Advanced Simple Profile. It was originally planned for video at very low bit rates for wireless PDAs, personal device assistance. So later the ISO committee decided to concentrate on an entirely new technology, so namely the encoding in the form of set of objects solid to form an image. The encoding technique can be chosen separately for each and every object available there. So this object-oriented encoding also opens up much richer possibility for processing on the receiver side. So MPEG 4, history of MPEG 4 is, so competitive test for video functionalities was done in 95. Development of the standard was done in 96 to 98. Stable final commitment draft for the video part is done in 98, and the standard is fixed at 1999. From that year onwards, so this standard is available. So feature of MPEG 4 is, so a scene is constructed of multiple independent objects in a frame. We can construct like that. So objects are merged into a scene on the decoder side. So a combination of different object types and different coding methods, so it is which is possible. So in MPEG 4, and improved coding efficiency with the bit rates of more than 50K to 50 megabits is provided here. The error resilient video coding is optimized for so mobile as well as for packet networks. So this is the working. Separate encoding of background foreground is mentioned here for object 1, 2, so object formation. So for each object, the encoding was done here, then it is fed to the multiplexers and it's producing as a bit stream. So then network layer, after that, it is given to demultiplexer, so decompression technique, then composition, rendering, and also we did it here. Finally, we produces the video image video. So MPEG 4, this is the object hierarchy for our decoding example. So scene, so person, so his voice, sprite, so 2D background, so what are the furnitures, so globe, desk, so what are the things are mentioned there. So in this hierarchy only they represent here. And this is the scalability by layered encoding in MPEG 4. So frame numbers, the enhancement layer is mentioned here in volume 1. In the volume 0 base layer we are having only 3 enhanced layer, but here we are having 4. So the MPEG 4 standard describes how to encode the objects, though the automatic segmentation of the object is not specified here. So object segmentation techniques, so what they are using here is, so blue screening, so automatic segmentation based on color, and the semi-automatic segmentation, say user selects object, the tracking is then done so automatically. So MPEG 4 features is similar to previous standards like MPEG 1 or 2. It's working on DCT, quantization is similar to MPEG 2. So supports B frames, and what improvement is done here is, so additional coding of objects which can overlay an image. So global motion, so compensation is done here. and 1/4 of the pixel precisions for motion compensation is done, and better image quality in low bandwidth is possible here in M.4. So computation is so intensive, and the compression rates are not significantly so better if compared with the M.2. So that's all about this the video. So compression standards, so that is MBEC 1, 2, and 4. So as per the syllabus, so we saw this working of MBEC 1, 2, and 4. So in the next session, we'll see about the broadcasting video standards. Thank you, students.